Hello everyone, welcome you all. In this video, we are going to discuss about full wave rectifier with the capacitor input filter. So in my previous videos, I have explained about what is meant by filter, and in that for half wave rectifier how we can implement the filter. So those topics I have discussed. So if you have not seen the videos, please check the playlist where you can find the link for the same. So in this video, we will discuss about full wave rectifier with the capacitor as a filter. So basically we are using the filter to get the smooth DC out of a pulsating DC. So pulsating DC is something like this, where it will be returning to the zero at some points, but in smooth DC the output will be something like where it is nearly equal to smooth or straight line. So this will be we will be getting after we will be passing this capacitor filtered DC from a regulator. So after regulation we will be getting a smooth, but in case of getting the less pulsated DC, we are using a filter. So filter simply smoothens the DC component. So we can use capacitor as well as inductor for this purpose, but in this video we are using capacitor as a filter because it charges and discharges because it charges suddenly and discharges slowly. So because of that property we can use the capacitor as a filter. So what the circuit diagram consists of is, as usual, the AC input is given at the input of this diagram. Then a step up or step down transformer is used. So mostly a step down transformer is used because the input will be 230 volt and 50 hertz. So a step down transformer of a suitable turns ratio will be used. Then it will be of a center tap type here, and the voltage across the output secondary of a transformer will be ESM. So two diodes are used. This is the circuit for half wave full wave rectifier. Then before the DC component goes to the load, it will be given to the capacitor, which is grounded on the other end. So the capacitor is connected in parallel with the load. So across the load the output voltage will be EDC, and this is the filter as shown in the figure. So immediately when power is turned on, the capacitor C gets charged through forward biased diode D1 to ESM during first quarter cycle of the rectified output voltage. So immediately when the power is given, the capacitor gets charged to ESM level, and in the second quarter of cycle the capacitor starts discharging through RL. So once it is charged to ES value, then in the second quarter of cycle, so it will start discharging through the load resistance RL. Once capacitor gets charged to ESM, again the diode D1 becomes reverse biased and stops conducting. For positive half cycle, diode D1 will be conducting, and for negative half cycle, diode D2 will be conducting. So in order to understand this mechanism, first you need to know about full wave rectifier, how it works. If you know the full wave rectifier, then you can understand this one. But anyway, I will explain about full wave rectifier in this also. So for full wave rectifier, what will be happening is, suppose this is the AC input, and the what output will be expecting is, for positive half cycle the D1 is forward biased and D2 is for negative reverse biased. So we will be getting output for the forward biased due to D1, and during D2 during negative half cycle diode D2 will be forward biased, so the output will be due to the diode D2. So for both positive as well as negative half cycles, the diodes to either one or two diodes will be conducting, so we will be getting a continuous output for the AC input supply. So this is how the full wave rectifier works. Now coming to the filter output, what we will be getting after the this output is passed through the filter is, so in this case from 0 to a point the diode will be the capacitor will be charging. So initially it will be having 0 charge, now it will charge up to the ESM point. So after that, the for second quarter of cycle, from pi by 2 to 3 pi by 2, the diode starts discharging through the load RL. So from A to point B, the diode from A to B, the capacitor discharges. So from A to B, the capacitor will discharge. Now again for negative half cycle, the diode D2 gets forward biased, and the capacitor again charges to point ESM. So this is the diode current. So in forward biased condition, the diode will be conducting, so the capacitor will charge to point C. Now again the capacitor, when it is charged to ESM, then for second quarter of cycle there is no current flowing through the diode, so it will start discharging through the load RL. So from point C to point D the capacitor will discharge. So like this for another cycles also it will continue, from this to this it will charge, and this to this it will discharge, like this. So previously what we are getting is the output will be like this. So where we are having a more repulses, but in case of the filter circuit, if you using the filter circuit, then we are getting a output which is somewhat smoother as compared to the previous DC output. So this is smoother as compared to the previous or half full wave rectifier output. So like this we are getting a more DC component as we are using the filter in the circuit. So if you pass this through the regulator, then we will be getting a output which is very smooth. So it will be something like this, straight line parallel to the x-axis. So this is the complete DC which can be directly used to the run the DC components. So this is all about full wave rectifier with the capacitor filter. So if you like the video, please guys hit the like button and subscribe the channel for more updates.